Good day, grade 10. So this will be our first lesson for the third quarter. This is wave optics. Okay, third quarter lesson for applied physics. So what is wave optics? Before that, let's have our trivia since we are not doing this online. So maybe you can play na lang mga Dora-Dora na lang kamunoda. So I'll be presenting the trivia. You try to answer in your mind. Like you give yourself 5 seconds. Then I will reveal the answer. So born in present day Iraq, he is known as the father of modern optics. Who is he? Okay, you may pause the video, you may research. By the way, may output for this ng video is only your comment. You comment one thing you have learned and you post that on our Google Classroom ng stream. Okay? So this is Ibn al-Haytham. So he was born in 1965 in Basra during the intellectual heyday of Muslim civilization. So one of his famous work is this Book of Optics, which was translated into Latin and has been used and has been basis of the modern foundation of optics. So optics is the science of light, more specifically optics a branch of physics describing how light behaves and interacts with matter. So I think when during the second quarter we were able to discuss about optics, specifically geometric optics. So it's important to note that we're dealing with wave optics, and wave optics is different from geometric optics. So when we talk about behavior properties of light, we're dealing with optics. Its interaction with matter and the construction of instruments that use or detect it. So when you make a magnifying glass, a telescope, or a lens, we are studying optics. So what's the difference between wave optics and geometric optics? Wave optics deals with the connection of waves and rays of light. It is used when the wave characteristics of light are taken into account. I think one of the most debated ng aspects of light is whether light is a particle or a wave, correct? So in wave optics, we deal with the wave-like characteristics of light. So wave optics deals with the study of various phenomenal behaviors of light, like reflection, refraction, dispersion, interference, dispersion, diffraction, scattering, polarization, etc. So that is for wave optics. So you have there a CD or DVD, and those ng vibrant colors or iridescent colors actually nang explains or physical manifestation that light behaves like a wave. It's otherwise known as physical optics. So wave optics is also known as physical optics. So what is the evidence or what are the evidences of the wave characteristics of light? So what I've said, you have there the DVD. This inang beautiful pattern of colors or iridescent colors actually is due to the wave-like characteristic of light. The iridescence that you see on the bubbles is also because of the wave-like characteristics of light. Okay? Because if light is a particle, of course, when you have a particle, a marble, if a marble is hit or is thrown at a wall, as a particle, it will bounce, correct? So, muna siya natawag na particle property, a particle nature of light, which is explained by the photoelectric effect naman, which we will be discussing later on. So what is the meaning, other than digital video disc, what is the most accepted and preferred meaning of the abbreviation DVD? So what is the meaning of DVD? Okay? Click, click. Digital versatile disc. So that is the accepted meaning of DVD. So you have there now geometric optics. So you discussed this one in your science second quarter, correct? So as you can see, now you have there the rays of light. Supposedly there are infinite rays, of course. So these are just a graphical representation. You have the lens. And depending on the lens, it will converge or diverge towards a focal point. So amo na siya kung geometric representation. But when you have a strong microscope, okay, looking again at the ray picture focusing above, you run into a problem. At the focal point, the rays all intersect. So supposedly, kung ga-intersect, dapat period, correct? Because infinite rays ma-intersect, so therefore dapat may infinite man siya nga density, correct? The density of the rays at this point is therefore infinite, which according to geometrical optics implies an infinitely bright focal spot. Di ba correct? Kung may infinity ka nga rays, makombine ta nga rays, therefore may infinite ka man nga bright spot, correct? However, this cannot be true. In fact, if you now use a powerful microscope, this is actually what you are seeing. You have there a radial pattern of light. As you can see, the centermost part is the brightest, and as you go ng further upward or outward, it becomes dimmer. There is a very small central bright spot, but also much fainter. Okay, ko. Rings surrounding the central spot, so the fainter as the rings go outward. These rings cannot be explained by the use of geometrical optics alone, and results from the wave nature of light. So this can only be explained by the wave nature of light, not by your geometric optics. So moving on, so the wave optics explains why the sky is blue. I think you already know the reason why this one. Okay, so nga blue ang sky is because blue has the light travels in waves. Some light moves in long waves, whereas some other moves in short wave. Here, blue light waves are shorter than red light waves. So meaning, mas blue, mas sensitive sa blue. All the light colors including blue light reaches the Earth's atmosphere and is scattered in all directions. Since blue light is shorter and a smaller wave, it is scattered more than any other colors. That's why sky is blue. Correct? Of course, may mga times man nga sky is red or orange or yellow. That of course depends naman on some other factors. But this explains why the sky is blue because it is bended or scattered more. So when the light travels along a longer path through the atmosphere, the blue light has been mostly removed. So kung lawig na, di ba ng laban, na for example, layabing sun, travel na a longer path, so tanan na nga blue light, gakadula na siya, anong gakabilin? Mostly red and yellow light. So basically, blue light is being removed as it travels a longer path, leaving mostly red and yellow light. Okay? So these are the pioneers in visible light. You have Isaac Newton and Christian Huygens. So I think you know naman Isaac Newton, but Christian Huygens is another proponent in visible light physics. So you have the refraction of sunlight, so you have white light and you have a triangular prism. It will now refract those light, creating this rainbow colors dispersion. So in the 17th century, two scientists had different views about the nature of light. So according to Christian Huygens, light daw are waves. Well, according to Newton, light are particles. So if light are particles, you have the double slit experiment by Thomas Young. So double slit meaning may buho, okay? So imagine this is a cardboard, may slit, may buho. Then may detector screen, then naman sa imong detector screen. So kung mag-fire ka na particles, di ba marble, obviously the marbles will roll in a straight direction because marble are particles. Correct? So mabudbud ka na balas, ang balas matulo lang di. Sa mo nga point ay matapik lang di, hindi siya mag-spread. Kaya hindi man yung wave ang balas because balas is a particle or particles. Okay? Kung wave siya, kung light naman is a wave, of course, wave exhibits the superposition principle of constructive and destructive interference. So therefore, it will generate this diffraction patterns. Yan. Amo na siya kung ang light are waves. It will create your diffraction or sometimes interference pattern. So ang center, sinaamo na siyang bright spot na nagapat-amat, dulong. Okay? Now, another principle or phenomenon that explains or proves that light is a particle or light or particles are your photoelectric effect. Amo siya gi-mention ko gina. So basically, photoelectric effect, imagine that light or photons are billiard balls. So electrons, the billiard balls, nga pag tiro mo ka electrons sa amo ni nga surface, usually metal, it will eject an electron nga particle. So this is a photoelectric effect. Kung magado billiard ball sa nga kung magaboy ka photon sa bula, sa another electron, ang mga electron matabog. So that is basically the photoelectric effect. You have the scattering, dispersion, so kung particle, amo na siya. Kung wave, amo na siya. You have the bandwidth. So wave theory and corpuscular theory. So the wave theory of light was proposed by Christian Huygens. So light is a wave that can transfer energy without transferring matter, because they have wavelengths, frequency, speed, and amplitude. Huygens also found that the speed of light in denser medium is less compared to the speed of light in a rarer or much lighter medium. less dense medium. But this concept was not readily accepted and was in contradiction to particle theory by Isaac Newton. So another name for particular particle theory is corpuscular theory. Isaac Newton described that light is made up of tiny particles. So corpuscular theory or theoria corpuscula states that the speed of light increases from rarer to denser medium. So yeah, in the beginning, wave theory of light was not accepted. Huygens proposed that light waves are longitudinal waves, but later it was found out that light waves are transverse in nature. Di ba transverse sa kay parallel na perpendicular, perpendicular ang iyong mga electric wave and magnetic wave, which means particles move perpendicular to the direction of the wave. Not to mention nga wala gin-accept ang kay Huygens nga principles because Newton was more famous. Mas famous si Newton compared sa kay Huygens. Okay? So, hindi na ako magatag quiz Ano siya dapat supposedly ang quiz. So, there you have it, the introduction to wave optics. So, I hope you learned a lot in today's lesson and please be sure to comment at least one thing you have learned after watching this video. Okay, we will have our online class next meeting because it is now dealing with problem solving. So see you next meeting. Goodbye.